Okay, I think we'll make a start. So thanks everyone. I'll start off with a karakia. Hui hui mai tātou I tēnei rā. Kia tipu tahi, kia ako tahi, tātou katoa. We come together today to share, learn and grow, and welcome everyone to the presentation. So just a bit of housekeeping in the agenda for today. So we'll start with the context and overview, looking at the key findings, go into the methodology and limitations of the research, perspectives and application of the project, and then have some Q&A at the end. It is quite a tight presentation, so if we don't get through all of the questions and answers, we'll attempt to respond after the webinar. Questions can be put into the chat, and we'll keep a look at those as they come through and compile a list, and they'll be answered at the end. My name is Adrian Feasey, and I'm the Climate Action Solutions Manager at Auckland Council. Other speakers today are Adrian Bouzonville, who's the Lead Climate Mitigation Advisor at Auckland Council, Ayushi Kachhara, who's a Senior Climate Analyst at Auckland Council, and Garry McDonald, who's a Director of Market Economics. Okay, so the emission factors we're presenting today are based on a consumption approach, so it's useful to clarify what we mean by this and why they're used. Many countries, regions and cities have developed production-based greenhouse gas inventories, and these focus primarily on greenhouse gas emissions from energy use within a geographical boundary through direct combustion, Scope 1 emissions, or consumption of grid-supplied electricity, Scope 2, as well as emissions from the treatment of waste. However, regions also consume significant quantities of goods and services, and the emissions embedded within those. And these are produced outside of their boundaries, i.e. Scope 3 emissions. And these are not included in production inventories, which is why a consumption-based inventory account gives us another way of looking at that information. Simply put, a region's sector-based emissions minus the emissions for goods and services exported out of the region, plus the emissions for goods and services imported into a region, make up a consumption inventory. And increasingly, the public and communities are wanting to take action on climate and reduce their emissions. And one of the best ways of understanding emissions and the profile of emissions for households is by doing a consumption emission approach. So we'll be talking about Scope 3 emissions, and Adrian B will be talking about this further later on in the presentation. But essentially, Scope 3 emissions include other indirect emissions, out-of-region freight, waste disposed of outside of the region, and transmission and distribution.
Our team was asked several years ago with reducing emission within household context and help inform and educate people as to where their household emission mostly came from. In 2018, C40 carried out an estimate of the 2011 consumption emission inventory for the region that highlighted that consumption-based approach emissions for Auckland were significantly higher than the regional emission using a production or sector-based approach. This initial assessment highlighted that the region consumes more than it produces, like 80% of the C40 cities, but also that there is a strong need to reduce consumption-based emission to drive our emission down. In order to reduce our intervention, to support our interventions, we wanted to refine our knowledge on the emission profile for the region and our also households in particular, as well as finding out which commodities, goods and services have higher and lower emission intensities. In 2022, Auckland joined the C40 Working Group on Consumption-Based Emission along with the New York, Tokyo, Phoenix and San Francisco. Through that working group, we learned about the different approaches that could be used, as well as the different data sources and key learnings from other cities like Portland, that was amongst the first city to develop a consumption-based emission inventory. What we learned from that journey is that a detailed city-level consumption consumption-based emission inventory is not critical. We can begin to work to reduce our consumption-based emission without an inventory, and many cities are already doing so. A hybrid approach is best as well. We can use activity modeling and use spend-based modeling where no activity data is available. Reducing emission from consumption requires change at every level, from structural interventions in supply chain and industry to individual choices and behavior changes. We also need to focus on our key consumption area and encourage innovation, particularly through tried and tested policies and specific intervention in key area of focus. By undertaking that work and better understanding consumption-based emission for the region, we recognize that the city and the community have an essential role to play in cutting the emission embodied in the product and services we consume, from food to building materials, for example.
Okay, so why did we do this research from a community and household focus? So one of our team's key focuses is reducing emissions at a individual, household and community level. We've had some experience with using consumption emissions. For example, we developed tools like FutureFit together with Wellington City Council, which is a personalised carbon calculator, and used some of the very helpful work done by Motu for that project that looked at consumption emissions and income. Following the publication of the Auckland CBEI, we identified the need for a consumption-based calculation method based on using spend data, given how readily available it is. Producing spend-based emission factors or intensities for a range of commodities provided a way to achieve this, which led to the work being commissioned by us. We also wanted to know which categories or sectors had high emissions to help us develop policy and projects, as well as identify possible gaps in our work program. So move to the key findings. So this chart shows emission factors for the study across different categories. And we have marked some of the top emitting products identified by this work specific to Aotearoa, New Zealand. Products within food include things like bananas, beef, bread, poultry, soft drinks. And this category has the widest range of emissions per dollar value. The highest emission factors in the food sector are for meat and poultry. Another example of a large category was the housing and household utilities sector, which includes products like electricity, property alterations, water supply, etc. And the emissions here go from 0.1 all the way to 1.5, 1.6 kilos of CO2 per dollar spent, which is the highest emissions per dollar spent in the study. Overall, the chart allows us to have a common scale by which to compare categories and get a snapshot of which categories have high emission factors. We'll go into further detail on these. So move to the methodology and the limitations of the research.
Yeah, I mean, the methodology that we've followed in the actual production of the actual emission factors is based on, very similar to that produced by Statistics New Zealand. It uses publicly available supply use tables that Stats produce as part of their industry survey, and it uses what's called input-output mathematics, which I'm going to talk a little bit about, but not too much, to actually do the emissions factor calculation. It's a top-down methodology. In terms of it, and then I'll talk a little bit about the difference between top-down and bottom-up as well in another slide. And it's also commodity-based, and I think that the key thing is that this commodity-based methodology allows us to facilitate a matching directly to the household economic survey. So we can look at the expenditure items in that survey and we can match them back to our calculations and then say for this particular commodity we've spent on, this is the emission factor. It uses it's based on the underpinning data for it is based on the GHG emission accounts developed by Stats New Zealand, and all that are fully compatible with the MFE's work on GHG emission inventory and covering the CO2 equivalents, nitrous oxides, methane, and a number of other gases there. Next slide, Adrian. And this actually is this is my major slide, but it goes through and tells us the step we went through to do the calculation. I'm just going to talk a little bit about it. So we've got a number of data sources on the side there. All the data, as I said, is actually produced from Stats New Zealand, with the exception of some emission factors that we actually pick up for the direct uses by households. That comes directly from MFE. We also require at the end a cross-check there on the consumption-based emissions as calculated by Stats. And what we found when we did that comparison is we're 99 point something or other the same. So basically we get the same results as Stats get, although Stats do a much more aggregate level picture of it, whereas ours is broken down by a base of 199 commodities. The steps in the calculation that we go through, there's 6 major steps in there, and I'll just run through them really quickly. The first one is we take production-based emissions, and then we calculate what's called a total requirements matrix. That matrix allows us to convert from the production-based to the consumption-based, and it's a number of technical mathematical steps in doing that, and that's laid out in the descriptions on the side there. A little bit of it is there. By actually taking that total requirements matrix and multiplying it by the production base, we get to the consumption base, which is what we've got there in the step 3. We also start to then apply those. We end up with our emission factors there by 199 commodities that are compatible with the supply tables that we've based it on, and we also then do the conversion through to the household economic survey in there. But there is some little technical bits in there that we've really got to look at. One of those things is that we need to remove taxes. We also need to allow for margins and take margins out of the commodities, and the margins themselves have their own particular consumption emission intensity. So we need to factor that in. We also adjust as we go through it, because we know that through inflationary pressures that we see in New Zealand at the moment, that year to year there's changes across time in terms of what you can buy for $1. So we've allowed for that as well in terms of it. So when we do it, we'll be doing updating, and as we go through time, we'll update that. We finally bring it all together, and that allows us to get the consumption emissions at that particular point. And we do that at the level of 268 commodities in the household economic survey. And that's at the subclass level. We can go levels below that, but we feel that the 268 commodities is sufficient for most of the work that the council will be involved in. And Adrian, next slide. Yep. So like I say, there's 3, 4, 5 different key outputs of it. The first one is we produce the actual consumption emission intensities by 199 commodities that are compatible with the input-output tables produced by Stats. We then convert those to the emission intensities at 268 household economic survey commodities, so we can get those 2 different ways of looking at it. Now, there's advantages in both of these. The first one on the SUT, the stats-based ones related to the input-output tables, they can be also used in other projects related to industry, whereas the household ones that are specific to household commodities are more useful when looking at the consumption emissions. So there's some dual purposes for the work. Click again, Adrian. All of this is summarised in a full technical report, which you can download from Knowledge Auckland. It's called the Consumption Emissions Modelling. Just download it from there and you can have a look at it. And also, available is, click again, Adrian, is actually some R code, so that we've made it all publicly available. All the calculations are available there, and the mathematics behind them can be followed. And for those who are used to using programming languages, you can download it here and use it. And that's a piece of software that's freely available. Click again, Adrian. There are strengths and weaknesses associated with the approach that we've actually used. It's comprehensive, and it covers all commodities that pass through markets. So things that aren't passed through markets aren't always included, but generally those have 0 emissions anyway, because they've already been made and already been used and accounted for elsewhere. It applies, another strength with that is it applies internationally recognised data sets and also industry and commodity classifications, and that allows not just comparisons within New Zealand and between regions in New Zealand who might use this, but it also allows comparisons with other nations as well. Many other nations use similar approaches to this. It is what is very different about what we have done, and it is slightly different from the Stats New Zealand approach, is that we used a commodity by industry approach to do the calculations. And what this means is that we can have more than one commodity being produced by each industry in our economy. and we can have in commodities. In fact, this facilitated a very, very exact matching between the household economic survey and what we've got within the input-output tables as produced by Stats. And that's the first time that's been done anywhere that I'm aware of, but it's a major improvement over the existing methodologies. Weaknesses, I think the key weaknesses of the approach is that it is a top-down approach. This emphasises breadth, so everything is accounted for, but it doesn't emphasise depth, which you often get with life cycle assessment approaches or process-based methods. The process-based methods tend to undercount. The top-down approaches tend to slightly overcount. So this is probably going to be you've got comprehensive coverage, but you've got an over-accounting. And the reason why you get some over-accounting is because of what's called aggregation bias. And that's because we've only got 109 industry-based data that goes into the actual calculations for it. Obviously, in other countries, they often have up to 400 to 500 industries that they're using it from, and that reduces some of that aggregation bias. But that's a limitation of what Stats have with their production of input-output tables. The key weakness of this method, and it's the same for most methods that are top-down across the world, it's not just something that's unique to here, is that and it's also that same weakness that exists in the Stats New Zealand process, is that the emissions embodied in international trade reflect a New Zealand production recipe. So we've had to say, well, we don't, to make sure that we include the international imports into New Zealand and account for those, because we account for all emissions, we've had to assume that they're made according to a New Zealand production recipe. So overall, I think it's also important to say this when you do any form of modelling like this, is that all models are wrong, but some are useful, and I think this is actually useful, but you do need to treat it as approximations, but it probably is the best approximations that we have to date available to us. Thanks, Adrian.
Garry.
So thanks, Garry. That's great. Garry's work has been a great milestone for us. Allows us to build emission profiles for households based on what we spend on, which is great because Stats NZ already collect the data on what we spend on.
Previous slide.
Next slide. Yes, as I mentioned, Stats NZ do something called a household economic survey, for those who aren't aware, which is a 3-yearly survey, and it collects various informations, including expenditure information from households. This includes information on average weekly spend, a dollar value spent on commodities that are already a list of 568 commodities, for which we also have emission factors from Garry's work. Combining these two allows us to build a profile of emissions per household. As Garry mentioned, it's a top-down approach where we combine the average weekly spend data, average dollar value per commodity, with emission factor per dollar value to get an emissions profile per household. The data is available from Stats NZ across various groups. They collect data. The household economic survey is like a snapshot over 1 to 2 week period from households across the nation, and the information captured includes things like the household composition, household size, income groups, the location of households, and yeah, that's the information we've used for this work. Next slide. So as an initial view, I think that's 2 slides down, 1 slide up. Yes, that's the one. So building an emissions picture for a household, an average household economic survey is only a survey, so it gives you an average household profile as opposed to total regions profile. So what we could do is get an emissions number for a household, look at the impacts from all these different commodities on and household footprint, and the graph on the right here shows exactly that. So we see the top leading emitters based on consumption, spend-based consumption day approach to be food, housing and household utilities, and transport. This is great. It allows us to, it also shows some of the other things like recreation and culture, which includes things like domestic air transport, or clothing and footwear, buying of furniture, which is covered in household contents, miscellaneous goods, includes things like personal care, jewelry, watches, buying of furniture. Oh, sorry, that's actually household contents. But yes, it gives a general overview of where people are spending and its impact on emissions. At a high level, this is great, but what we are also able to, when you think about emission reduction interventions, we really need to go a level deeper, where we can actually also see what is the top contributor from the food sector, where do we focus our efforts, and similarly for other sectors. So basically asking the question, are people from the data set we have available, asking questions such as, are people spending more on things that are also highly carbon intensive? To dig into that, next slide. This slide here basically just shows the exact same chart as before on the right, highlighting the food sector, and the food sector, what the food sector is made up of, is presented on the left side as a stacked bar. Food sector in the database has about 69 to 70 products in there. It's too many colors to fit on a scale, but what this shows is the top contributors in the food sector. It's dominated by meat and poultry, dairy, grocery items, and there's one vegetable floating around there somewhere. These are only preliminary results. We're still looking into that, but the key thing is 40% of food consumption can be attributed to meat, poultry, dairy. That's a great finding. If we do the same analysis for transport and housing and household utilities, which were the other two top sectors, for housing and household utilities, 30% is dominated by electricity. And similarly for transport, 90% of it is from private vehicle purchase, use, and maintenance. That's great. This level of detail allows us to think about future projects, allows us to think about interventions, but it also has its limits. And that's what we're trying to explore at the moment. Household economic survey, and I'll come to that later. But yes, our ultimate aim is to be able to build a regional inventory using this information and use other data sources to increase our confidence in these numbers. Next slide. What we've done is taken that approach to a national level at a preliminary level using 2019 information on spend base for the entire country. We've tried to look at what a typical household looks like at a regional scale. Auckland and Wellington clearly stand out, and that just reflects higher spending in those regions. A big disclaimer here that the boundaries for this work are very different to what previously published per capita per person emission entail. So they're not directly comparable. It gives us a number, but we need to do more work into making them directly comparable, which is what would be our focus in the coming few months. What also needs to be kept in mind this is only an average household profile. What we need to factor in is the size of households, the income groups, the location of households, and how that affects the numbers, and what is the range of emissions per household in these different locations. Coming to the limitations of using household economic survey and this approach itself, overall, it provides a reasonable approach to quantify a household emission profile, but some of the limitations that we've come across and are constantly discussing are it's only done once in 3 years. So the time period isn't as frequent as we'd like it to be. The sample size is still small, so it doesn't allow comparison of Auckland CBD with North Shore, for example. And to go across these barriers, what we're currently doing is trying to explore other data sources which are more admin-based, such as building a food ecosystem using barcode data from GS1, more recent and higher resolution energy consumption data that we could probably source from Vector, more recent and highly resolved, spatially resolved transport data as well to corroborate that into the picture. So as Adrian B mentioned previously, using a hybrid approach is what we would try and do in the future, but this is where we are at. And once again, these are preliminary, yet to be published, but that's our findings on the household economic survey and household consumption.
This work can also be used to support a Scope 3 calculation. While Scope 1 and 2 are really easy to calculate, Scope 3 covers a much broader range of information across the value chain and is more difficult to calculate. The Greenhouse Gas Protocol guidance recognizes that spend-based method can be used across various categories for Scope 3 accounting. However, in most of the categories, it's recommended to prefer methods that use supplier-specific, distance, fuel-based or hybrid methods that account for some specific data collection from the manufacturer, the supplier, or the value chain. The spend-based method is generally effective for screening purposes and when no other methods can be applied due to data limitation, for example. It must be noted that it doesn't mean that the specific data are more accurate. Data from the supplier could be less accurate from the industry average. In any case, data quality need to be assessed and discussed properly. I encourage you to read the guidance from the Greenhouse Gas Protocol as they provide nice decision tree diagram to support decision making for each category. For the categories where spend-based method can be used, those highlighted in orange in the figure, then it must be used with care as well. You need to understand the limits of the study, as we mentioned earlier, as well as apply those emission factors in the appropriate context. There is limited details on what each commodity of the emission factor covers, as they are connected to the 199 categories of the supply use table and across the household economic survey classes and subclasses. So please ensure that you review the entire list before selecting one. Sense check the value with other publication and data available, including international publications. Use the emission factor in the relevant context and along the appropriate guidelines, and reference the emission factor appropriately. Quoting Auckland Council 2003 is probably not enough, and the category should also be provided for transparency. This work can also be used to support decision-making process. There is a rising concern to inform decision-making process and budgeting to demonstrate how our investments are delivering on climate. This is the case for our regional long-term planning process, which is often CapEx and OpEx driven. Spend-based approach can be applied to CapEx OpEx spend. You simply select the most relevant emission factor for your project and multiply by the proposed budget to estimate the annual footprint of your proposed project or investment. That's pretty easy to do. You can then estimate the yearly greenhouse gas of your CapEx OpEx spend as presented on the top graph for three indicative projects. But this doesn't show the full carbon picture. Wall of life emission, including end of life stages, indirect emissions such as the user emissions, as well as the emissions beyond the project boundaries, are not accounted in the CapEx OpEx estimate. As part of our current LTP process, we encourage project developers to estimate the removals of carbon sequestration or the carbon removal or the carbon sequestrated by the projects that are seeking funding for. Once this has been estimated, even with high uncertainty, this can inform the decision-making process, and only accounting for wall-of-life emission can support efficient decision-making. So such scope support decision over the overall benefits of the project. Is the project worth the investment compared to the little benefits, expected benefits? This also allows some project prioritization. For example, here, the project in yellow in the middle generate greenhouse gas, but no removals. This may be acceptable if other outcomes are sought, such as safety, but if the primary purpose is to reduce greenhouse gas emission, then this is probably not a good investment compared to the two other projects that are definitely removing or sequestrating carbon. Once the emission of the removals has been accounting for the whole life cycle of the project, then it is possible to confirm the overall alignment of the investment with our decarbonization targets and pathways as presented in the below picture. There are, however, a few limits that you need to be aware of, and one of those relates to the question that popped up in the chat. But a higher dollar spend does not necessarily mean that it translates into more greenhouse gas emission, but there is often the opportunity to do more with less money. A more specific approach should be considered and sometimes combined through a hybrid method or a hybrid approach to provide an appropriate picture and avoid the default emission factor for the entire category, which is quite an average on a big picture. For example, different emission factor would be required to compare two different transport projects. This is particularly the case for the construction of a bus infrastructure compared to the reallocation of an existing lane for a high-frequency buses project. Those two would have different emission factors that would need to be accounted for, but that study doesn't drill into those details. So overall, the more detail are provided, the better the assessment, but it is critical to have those high-level figures at the early stage before diving into the optioneering and the design stages.
Right, thanks, Adrian. So this is a short case study of how we've used the emission factors for a current project we have running. It's FutureFit, which I mentioned earlier. So it's a tool offered by Auckland Council that enables individuals to calculate their carbon footprint, as well as understand and select actions they might take to reduce their footprint. So the tool uses a range of emission factors and it's based on income information entered by the user. And those users can be throughout New Zealand. It's not specific to Auckland. And FutureFit's currently used by a number of councils and New Zealand-wide businesses. So using the consumption emission factors from this report, we're able to switch out some of the original emission factors, which were done several years ago under a different model. And that's helped us increase the accuracy of the outputs. Okay, so final thoughts and next stages. So I guess, as we all know, good data and methodologies are critical for climate action planning, and they can take some time to develop. What we've sought to do is to contribute to the ongoing conversation and work in this space, and we're really keen to build off the good work that SATS NZ have done with creating New Zealand consumption inventory. We definitely consider it work in progress. We do have some work in the pipeline, which is to downscale the New Zealand-wide factors and inventory to a regional level, and that should be able to be used and adapted by other regions throughout New Zealand. Further work is required to define the import-export tables for New Zealand, as well as across the regions. We are hoping to do future updates with the tool to update it as we get more information or more regular updates coming through from Stats NZ or the Household Economic Survey. And I guess just lastly, this is obviously a huge topic, and today's attendance suggests it has broad appeal, if you can say that about consumption emission intensities and factors. And we look forward to collaborating with others in this space. So thank you very much. Thank you to the presenters, and we'll move to the Q&A section. Here's our contact details too. And the slides, as I mentioned earlier, will be made available, as well as a video of today's presentation. Thank you. Right.
In which order you want to tackle those? Guess I might pick on that question about the T-shirts and the T-shirt with a cost of $80 compared to the $10. That's definitely something which is not accounted. We've got an emission factor which represents the overall average of that category. If you spend $10 or if you spend $80, we take the assumption that the higher the spend, the higher the footprint. And that's, again, a strong limit of that study, or that overall, not necessarily just the study, but the overall approach. And that's why spend-based approach should be approached with care. And that's definitely why it's not the most preferred recommended approach from the greenhouse gas protocol. It's really the approach that should be used when you don't have any other alternative to do so. So for a T-shirt, if you really want to dive into the textile industry and those sector-based aspects, then a life cycle assessment is definitely the most appropriate tool. And a T-shirt, even if it's costed $80, if it's coming from such manufacturer, won't have the same footprint as same value shirt coming from another manufacturer coming from another country. So there are plenty of different nuances with the origin of the product, the manufacturer, and so on. So for those projects and those more refined application, I would definitely encourage you to cross those data with more accurate data coming from life cycle assessment database that are available out there. The benefits of that approach is really to be able to compare a T-shirt compared to another piece of equipment, and really to compare apples with bananas or other products like that, or meat against other products. But it's not intended to really see the exact carbon footprint of that textile product. So just be aware that you should select the average and be aware of that limit when discussing the results or using those emission factors to carry out your calculations.
Thanks, Adrian. Let's go through the questions.
I could jump in if you want, Adrian,
Yep,
and just talk about
Right.
the actual comparison with the actual dollar spend emission factors from ThinkStep. ThinkStep, we're a peer reviewer for the piece of work, and they've been through that process. So we would assume that they've used similar methods for calculation at the end. We would assume we would get similar results. They gave it a very positive review in the peer review of the actual work.
Okay, perhaps the next question regarding meat and poultry being one of the highest contributors to greenhouse gas from food. Is that specific to meat and poultry that is farmed and raised in New Zealand?
Yep,
So,
I can answer that.
Yep.
Well, you go ahead.
There you go, Garry.
I was just going to say that, yes, our production recipes are based on New Zealand production patterns. So those are mainly based on New Zealand, and most of our products in both meat and poultry are all sourced locally. We don't source them internationally.
Next question, can these categories be mapped to ANZ codes?
Yes, they can. There is a difference here in that the ANZIC codes are by industry classification. So this is when I talked about the joint products things and the method. The ANZIC code, we only have one product per industry. So if you map to ANZIC, you're only matching one product. What ours does is actually uses a commodity classification, allowing us to map many commodities to a particular industry. So I would suggest for the person who wrote that question that they have a look at the technical report, but also look at the ANZIC ANZCC classification, which we use, which is a commodity-based classification rather than an industry one.
Garry, is it okay to use the data set published for teaching purpose? Yes, yes, that's fine, as long as they use in the relevant context. Yep. What is your opinion on external application of inflationary data through the CPI, PPI?
Yeah, I think it's really important that we account for inflationary change. And the reason is because this work is all based on 2019, 2020, depending on which part of it you're looking at. And of course, we've had quite big inflationary pressures across the New Zealand economy between then and now. So if you were to take 2019 expenditures, you do have to convert those back to, or 2023 expenditures, you do need to convert them back to 2019 expenditures when you use it. There's a need to do that.
Thanks, Garry. As you don't include sequestration from the LUCF sector, to what degree does that account for differences found between these findings and a production approach?
There are overlaps between that consumption-based approach and the sector-based approach, as we highlighted at the beginning of the presentation. Those numbers don't match because the methodology and the boundaries are not the same. So we don't account for the land use change, and forestry, and there are a couple of others which are not accounted. The agriculture emission of the entire New Zealand sector is not accounted. We only account for the proportion which is used or spent or consumed by New Zealand customers. So that's why the numbers are difficult to compare, I guess, and you can't match the usual New Zealander carbon footprint, average carbon footprint, with the household economic survey calculation that we've done. It's a different scope, a different boundary, and there is not just that sector which is not accounted. So the focus is different, the application is different. We are coming up with different numbers, that's fine. And again, learning from the C40, the idea is not to come up with the exact numbers, but more to identify the key area where we need to work and focus our attention on for our intervention. So really having those key focus area is definitely the key objectives for us.
Thanks, Adrian. Question here about, can we clarify the term domestic fuel?
That's a classification used in the Stats NZ table, but without looking into further, domestic fuel would be it's anything classified as other fuel after solid fuel, or liquid fuels used in the household. But yes, that the numbers appear high for that, and it is a question mark to understand what it means. Yeah, so we definitely need to look deeper into what that means.
Okay, thank you. There's a question, how does the stacked food graph relate to emissions dollars metric used earlier? E.g., if meat was cheaper compared to strawberries, how would the CO2 per dollar spent be represented?
Garry,
Sorry.
maybe Garry.
Oh yeah.
With me, okay. I would just say that there are two different emission factors for both of those categories. So I don't think they're misrepresented in any way there. They do have different emission factors for them. Ayushi, you might want to add something else.
I was just going to say, I was going to reiterate what Adrian B said before, that it is basically the approach here is basic. If you spend more, and if the emission factor is higher, then it will come out on the top. So it's completely based on spending. And yes, as Garry pointed out, the emission factor for strawberry and meat and poultry are different.
Does the study take into consideration the number of people in a household, e.g. a household with 2 people spending $100 on groceries versus a household of 5 people spending $100 on the same groceries?
Yes, so that is our next step. What we presented is an average typical household in Auckland and for other regions. What we need to now do is build a profile for households, and that would factor in things that you've suggested, which is the size of household, the composition, the income group, where it is. Yeah, so that's a future piece of work for us.
Thank you. And possibly one for Garry. Are emissions from international portions for the commodities included in the calculation?
Yes, definitely. So all the imports into that are imports, and it's like Adrian B said before, is that we account for, it's consumption based. So if households consume an imported good, they are accounted for. So the embodied chain of all the products that they would use in that import are actually accounted for too. But remembering that it's based on New Zealand production recipes for that type of commodity. So another country may have a different way of producing those. Generally, it's so aggregate that they're not too different. And this is a problem with the methodology around the world, is that when you come to imports, how similar are the practices in the way that they produce goods between countries? And we're assuming that they're produced in the same way as New Zealanders would produce them in that project, but they are fully accounted for. Imports are fully accounted for.
Thanks, Garry. And possibly related to that, is there a scale to compare the accuracy of each dollar based on EF? I think perhaps they mean by for each emission factor.
Yeah,
Yeah.
All we've got is that what we have done. We haven't really. I'm not sure what the question really means, to be honest. But I think that we have compared them amongst each other, and we're sure that the calculations are done correctly in the process for that. But we haven't been able to say that there's an accuracy component within that. Stats New Zealand does produce with their input-output tables a standard error. So if you're talking about a statistical things, to actually put a curve around it and to say, like, it's within this level of accuracy, that possibly could be done. We haven't done it in the study, but it could be done using the standard areas that are produced for output for each sector in the New Zealand economy. But that piece of work hasn't been done here, but it could be undertaken.
What we also identified is that we are certainly more accurate on products which are produced in New Zealand and generated in New Zealand and exported, because we know the carbon footprint and we are able to better calculate and estimate that footprint for locally produced products, compared to some products which are heavily imported compared to that aspect. So in the report, and I think in the table as well, we highlighted the one with the import percentage or import share. And I guess that's also something to keep in mind, is the accuracy might change based on the import-export proportion.
Thank you. Next question. Do you have time series data for understanding trends?
We surely do. We'll require another detailed webinar to go into all that. We surely do. Stats NZ have uniform data from 2007 for every 3 years. So for that, but if you mean for emission factors, that was based on 2019 only, but deflated. If Garry may want to add.
Yeah, you could actually do it. You could you could do a 2000, the input-output tables, which is based where the emission factors are calculated from, are calculated regularly by Stats. So the last one was a 2021, and the one before that was 2013. So you only have 2 snapshots there, and the one before that was 2007. So I think you could do them over that period of time, but I don't think the emission factors will change greatly through time, but what does change through time is the way we spend on household goods. So it's probably more, as Ayushi has said, actually having the time series related to the household economic survey, which is generally done every 3 years or so, is probably more important than calculating the emission intensities regularly, because I don't think the production patterns change much. I mean, industries don't change the capital and the way they make things dramatically year to year. They tend to invest, tends to run for 10 years, 15 years, and then they reinvest and improve it. But generally, once they're established, they're very similar.
Thanks, Garry. What has been the most interesting / surprising finding? Well, I think for my part, I think seeing food when we use the household economic survey, I think that was a really interesting finding, and speaks, I think, to the larger body work around understanding the food system. There's a number of projects, I think, happening in that space at the moment. Do you guys want to comment as well?
I think for me, it was the transport, 90% being attributed to private vehicle purchase, use, and maintenance. That was a, big one for me.
Yeah, I would just say that for me, the interesting one is that a commodity that might seem benign, like you're purchasing something from an accountancy service, or you're producing some type of service and you don't think it's actually using emissions, actually it's got a big chain behind it, and it does actually use quite a lot of emissions because it's purchasing things through a whole production process. So some things that appear benign actually have quite big appropriation chains.
I'll actually also just add that the biggest finding for us as a group has been that it's been a very hard process. It's not easy to be able to do this, even though it's just a simple multiplication. There are limits and assumptions to be aware of. And every day we're finding a new question. So that has been interesting.
Might just pick up the last question on the food waste. So no, food waste is not included in that, not through the household economic survey, because it's not a direct spend by the household. However, we've got an ongoing work done by our colleagues in the waste team around the food mapping for the Auckland region, where we identify the different flow of the food across from the production to the processing, the distribution, and up to the waste from the household, generating the waste all along the product and the value chain of that. So we are hoping to distribute that study in a couple of months as well, which would provide some interesting value in terms of tonnage of waste and emission factor associated to those waste at the different stage of the value chain. So it's not necessarily just household waste as being the end product. We identified as well that there is a significant generation of waste through freight, through processing, through the retail as well, but they don't necessarily have the same carbon footprint. We looked at the carbon footprint of the end user here, of the household. The carbon footprint from the producer, from the retailer, from the freight is different. So we are working on that topic, and we'll definitely keep you informed of that topic, because that's a really interesting study building on that, on the finding of that one specifically for the different categories.
Next question, can the factors emissions info be shared on product packaging to help people make better purchasing decisions? I think it's an interesting idea. It probably requires some more work to get down to a specific product level, and I don't know, whether that is something that is being looked at a nationwide or a international wide level. But certainly giving that sort of information to consumers would be of value.
Yep, that's definitely something which is starting in Europe, giving like eco scores on products, more with the score A, B, C, D, like the energy scoring as well. And yeah, that's the beginning of the journey, and we can see some good signs in the retail industry as well, who are quite keen on shifting the change and shifting the behavior of the consumer as well on that. So yeah, at the moment we see some positive changes, and we hope to build on that, not necessarily to provide the exact emission factor per dollar spent as the number, but definitely for the wider audience and the wider public, the ABCD type scoring is a good approach.
Are you able to share summary information that is more detailed than in the presentation today? Currently, the report shared contains very detailed emission factors, but not the interpretation of the results as you have shown. Yeah, I think that's thanks for that feedback. I think that's something that we can certainly have a look at
Yeah, and that's definitely a work in progress, and that's why we will send you the slide after, but you will see that it's a written work in progress to be published, as Ayushi mentioned. We are working on that. We are working with NZStat to refine the sources and to refine the assumption and to make sure that it makes sense. So what we presented was potential application, how we are planning on using it. That's the plan. If you want to corroborate, we are more than welcome to join forces on those. It's coming up over the next few months, and yeah, work in progress. So no information to share as such for the household yet, but once the number would be properly peer reviewed and so on, they will be published.
Have we got time for one more? Okay, what implications does this have for council's own spend? How can it be used by council procurement to reduce emissions of goods and services used by council?
And that's exactly a good application as well of the scope 3 and the decision-making process. I guess those give you some information about what's the average of that, so that allow us to calculate what is the likely carbon cost of our spending, our procurement, and our emission on that. So that's really linked to the LTP package as well. The procurement being one stage of that approach as well. Again, those emission factor per dollar spent shows the really high level pictures and an average industry average estimate. When you come down to a procurement stage where you are able to have a bit more influence on the product or the optioneering or the option that are developed, that's where you are encouraging your supplier to provide a bit more detail in the assessment to really avoid, reduce, mitigate those emissions as much as possible along the design stage. And so I guess we all have a role to play, and Auckland Council has a strong one through procurement and through its expenses and investment. And that's a journey, but we are working on it again.
Okay, I think we'll make a call there and call it. So thank you to the presenters and everyone who made this happen today. Thanks for your questions. As mentioned, it's an ongoing piece of work, so we look forward to hearing from people who are interested in the space. I'll just close the webinar with a karakia. Unuhia, unuhia, unuhia mai te uru tapunui, kia wātea, kia māma, te nākau, te tinana, te wairua i te ara takatū, koia rā e rongo, whakairihia ake kia runga, kia tina, tina. Humie, huie, taikie.
Thank you.